and welcome back to another episode of Teach Me in 10. Here we invite scientists to describe their research in less than 10 minutes. Today's episode is sponsored by MGI Tech, a leader in developing essential tools and technologies that drive innovation in life sciences. MGI provides digital multi-omic solutions across fields like precision medicine, agriculture, and healthcare. As one of the few companies capable of independently producing clinical-grade gene sequences, MGI's platforms offer high-throughput capacities from gigabases to terabases, catering to a wide range of applications. I'm Brie Foster, science writer at Technology Networks, and I'm thrilled to introduce our guest, Samantha Mendonsa, product manager at MGI. Samantha is an RNA biologist with a background in neurobiology and next-generation sequencing. She completed her PhD at the Max Delbrück Center for Molecular Medicine in Berlin, Germany, and now supports MGI's product line in microbiology, agrigenomics, and high-throughput sequences. In this Q&A, we'll explore the evolution and importance of NGS technology and its impact on fields like population genomics and agrigenomics. We'll also dive into MGI's DNBSEQ technology, which enhances sequencing accuracy using nanoball technology. Hi, Samantha. Thank you so much for joining us. Could you start by giving us an overview of next-generation sequencing and what excites you most about this field?
So, actually, in preparation for today, I double-checked when the first commercial sequencing instrument was available. 2000. So in just over 20 years, it's fascinating to see how this technology has evolved. Like before this, we had Sanger sequencing, where you could only sequence like one single strand of or DNA fragment, right? But with NGS, we can sequence millions of fragments simultaneously. And because of this technology, we can now sequence around 200 genomes in a single day using one of our high throughput sequencers. 200. That was unheard of. Plus, with all the advancements with NGS, it's really incredible to see the directions that we move in. It's not just about reading DNA and RNA anymore. You can even look at the epigenome using sequencing.
That's brilliant. It's come so far in so little time. It's extraordinary.
Yeah.
So why is NGS so crucial in research and healthcare?
Well, for most biological questions that need to be answered, NGS is one of the techniques. It's widely used in research, but as you said, it also opens the doors to many, many other areas like healthcare, etc. So four main areas come immediately to my mind when I think of, where NGS is most applied. One is population genomics, where you understand genetic differences between populations, how they're related. Then the second is agrigenomics and molecular breeding. So where you assess the crop, livestock, how they can be bred. Third one is personalized healthcare. As you mentioned, healthcare is a huge topic for using sequencing technologies. This can be used for identifying specific mutations that might make a patient more responsive or unresponsive to certain treatments. And lastly, consumer genomics, helping people explore their ancestry or health related topics like gut microbiome. Right now, there are actually a lot of companies focusing on gut microbiome health at the moment.
It's a fascinating topic, something I'm also really interested in. But how does MGI's technology compare? And can you explain what makes DNB-seq technology so special?
It stands out for a unique approach to sequencing. So instead of using a linear template, MGI uses rolling circular replication from one single stranded circular DNA template to generate what we call DNA nanoballs. So these are multiple repeats of the single DNA template. And then we sequence these nanoballs. So with this DNA nanoball technology, there are two major highlights. One, better data quality, because it eliminates PCR bias, because it's rolling circular replication. It improves accuracy, decreases duplicates, and virtually eliminates index hopping. But in addition, with better quality, it's also very cost effective.
So, what
Yeah.
is the advantage of these nanoballs for the different applications?
So, as I just mentioned, the major highlight or key advantage of using DNA nanoballs or this DNBSEQ technology is better quality because they're the exact same copies of the original template, and that's how we can ensure accuracy and reliable data with much fewer reads. So, this is critical whether you're working in cancer diagnostics or whole genome sequencing, particularly when you require fast and affordable data from large sample cohorts.
So, how many different sequencing platforms does MGI offer? What makes each unique?
Oh, how many? Well, MGI offers a range of platforms, all the way from portable and benchtop models to really high throughput systems. Like each platform is designed with different capacities and runtimes in mind. So users can take advantage of this technology based on their specific needs. But it's not just about size and output, it's also about speed. For example, one of our lower throughput sequencers, the G99, has one of the fastest speeds among those with the same throughput in the world. It can perform one paired N150 run in 12 hours. Plus, we also offer BIT solutions to complement all of these platforms. So it's a everything.
The complete solution. How do different output levels and runtimes influence platform selection for specific applications?
So, for example, if you're in a hospital lab with a lot of patient samples, speed is of the essence, right? You want to give your patients the results as soon as possible. So you choose a smaller, faster platform, like I just mentioned, the G99. But when you do population genomics or the new hot topic, spatial transcriptomics, you typically want to wait, can wait to fill up the run and are rather more concerned about the amount of data than the turnaround time. So in these fields, researchers often deal with really large scale data sets, which is why data volume is more critical than speed. So what they do is they focus on capturing comprehensive data to identify patterns and insights across multiple samples or within tissues. So in these cases where you have large amounts of data and you're looking for patterns and you have a little bit of time, you'd opt for a higher capacity platform like our T7. But additionally, no matter the application, whether it's clinical diagnostics, large scale genomic studies, or even emerging fields in the multi-omics sphere, all of MGI platforms provide the flexibility to adapt to your lab's specific needs. They're versatile and they can handle a variety of applications and any type of libraries.
Okay. Well, leading on from that, so you say any type of library. Is that bacterial, plant, human, any type?
Yeah, exactly. Yes. So we've made sure that you can apply any type of samples, but also you can sequence any types of libraries that have been adopted for other sequencing systems. Because we use DNBSEQ technology, we the method is slightly different than other sequences used. So we've also made a quick conversion step that can make this transition seamless to adopt other library types to be sequenced on MGI. Yeah.
Brilliant. Is there anything else you'd like our viewers to know about MGI?
Well, it is worth mentioning that as part of all of our BIT solutions that complement our sequencers, we also offer secondary and tertiary data analysis software. But most importantly, we are the only company providing open and comprehensive lab automation, covering everything from sample extraction all the way to library preparation, in addition to all of the sequencers I spoke about today and the BIT solutions. So MGI has definitely got you covered. But Apart from all of these products, we also provide comprehensive support and expert guidance, ensuring that all labs can seamlessly adopt everything that we offer, so all of our platforms.
That was brilliant. Thank you so much for sharing those insights, Samantha. You've been an amazing speaker. That is the end of our chat. As always, thank you for tuning in to Teach Me in 10. Don't forget to subscribe so you don't miss more quick science bites. See you next time.